Hi and welcome to Pre-Calc 30 with Miss Verity. Today we're going to be looking at section 3.2, the remainder theorem. So what we're going to focus on is describing the relationship between polynomial long division and synthetic long division, dividing polynomials by binomials using long division and synthetic division, and explaining the relationships between the remainder when a polynomial is divided by x subtract a, and the value of the polynomial is fa. We're going to split this up into 2 days, a 3.2a and a 3.2b. I will let you know where to stop. So long division. You can use long division to divide a polynomial by a binomial. So p of x divided by x subtract a is equal to some quotient, q of x, plus r, which is our remainder, divided by that binomial. So p of x is the polynomial that we're dividing. X subtract a is that binomial it's being divided by. And q of x is the expression that results. R is the remainder, or your leftovers. And we're also, to check the division of a polynomial, verify the statement p of x is equal to x subtract a, q of x plus r. Okay, so if we're going back to grade 4, and we're going to do some long division, we're doing 436 divided by 3. So this is not using a calculator, this is using our brain. So 436 divided by 3. So what we want to ask ourselves is, how many times does 3 go into 4? Well, it goes in once. It doesn't go in evenly, but that's okay. So we write our 3 below, and we subtract. So 4 subtract 3 is 1. We bring down our next number. Now, how many times does 3 go into 13? That goes in 4 times. So 4 times 3 is 12. And if we subtract those, we're left with 1. Bring down our next number. How many times does 3 go into 16? It goes in 5 times. 3 times 5 is 15. And when we subtract those, we're left with 1. So that means 145, remainder 1. If we wanted to verify that, we would say, I'm going to write it on the other side here, 436 would be equal to, well, 3 times 145 plus 1. And you can either do your long multiplication, check with a calculator. That is true. Therefore, we know we've done the question right. Okay, so now using that same idea, we are going to divide x squared plus 2x plus 5 by x plus 1. X squared plus 2x plus 5. So there's some steps associated with that, and I'm going to write them on the side, and you may want to do the same. So 1, we are going to look at the first term only. Oh, before I get too far, you need to make sure that your polynomial that's under your division symbol is in descending order. So we're going from a squared to a linear to no x term. Okay, so then we're going to ask ourselves, what multiplied by x gives us x squared? Your answer goes above. So if we think we're only looking at the first term, x times what gives us x squared? Well, that is x. Our second step is you take your answer, or take your top number, whatever you want to call it, and you're going to multiply it by your binomial, or in this case, by our x plus 1. So if we want to scribble that on the side, I'm going to say, okay, x, which was what was up top, times x plus 1. That gives us x squared plus 1x. Step 3 is we're going to subtract those two. But remember our brackets. So we're going to subtract that term. So what that means is x squared subtract x squared. Oh no. Okay, cool. X squared subtract x squared is 0. 2x subtract 1x is 1x. And then our last step is bring down the next term and repeat. So we're going to bring down our 5, and it's a positive 5, and we're going to start that over again. So x times what gives us x? Well, that's 1. And if we want to think, okay, 1 times x plus 1, well, that gives us x plus 1. And we're going to subtract that whole term. So x subtract x is 0. 5 subtract 1 is positive 4. We have no more terms to bring down, so we are done. That means we have a remainder of 4. If we want to write it in the term of our p of x equal, or like divided by x subtract a statement, we're going to say that x squared plus 2x plus 5, which was our p of x, divided by x plus 1, which was our x subtract a, is equal to our q of x, which is our quotient, that's our x plus 1. That comes from whatever is on top of our dividing symbol, plus our remainder over that binomial. And last but not least, we're going to have some restrictions. And we know that in these, we cannot have a denominator that goes to 0. So we know that our x plus 1, that cannot equal 0. So x cannot equal negative 1. Example 1. Divide the following using long division. Express the result in the term of p of x subtract a is equal to q of x plus r over blah, 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 blah. State any restrictions. Let's start off by stating our restrictions. Our restrictions always come from whatever that denominator piece is. So in this case, x plus 2 cannot equal 0, so x cannot equal negative 2. All right, let's get dividing. First thing we're going to check is that our binomial is in descending order, or sorry, our polynomial is in descending order, which it is. So 2x cubed plus 5x squared subtract x subtract 6, and that's being divided by x plus 2. Okay, first thing you're going to think to yourself, x times what gives us 2x cubed? Well, that is 2x squared. So 2x squared times x plus 2, that is 2x cubed plus 4x squared. And we're going to subtract that whole piece. So 2x cubed subtract 2x cubed is 0. 5x squared subtract 4x squared is positive x squared. All right, we're going to bring down our next term, which is a negative x. So x times what gives us x squared? That is positive x. So x times x plus 2 is x squared plus 2x. We're going to subtract that. And we end up with, well, x squared subtract x squared is 0. Negative x subtract 2x is negative 3x. And we have one last term to bring down, and that is negative 6. So x times what gives us negative 3x? Well, that's negative 3. So negative 3 times x plus 2 is negative 3x, subtract 6. And if I subtract those, well, negative 3x plus 3x is 0. 6 plus 6 is 0. Meaning we have a remainder of 0. And if we want to rewrite in that term, so it asks us to put it in that p of x form, that looks like 2x cubed plus 5x squared, subtract x, subtract 6, divided by x plus 2. That is, so whatever is sitting on top, so 2x squared plus x subtract 3, plus x subtract 3. And then our remainder, which if we want it in that form, we have to actually put our 0, because it's asking for us to put it in that remainder over x subtract a. We need that 0. Example 3. All right, when we first look at it, our first check was we want to make sure we are in descending order, which notice our squareds and our x's, we're not in descending order. So x cubed plus 3x squared subtract 2x plus 5. And x subtract 1 is our binomial. So our restrictions, x cannot equal 1. And we'll start dividing. So x times what gives us x cubed? That is x squared. So x squared times x subtract 1 is x cubed subtract x squared. X cubed subtract x cubed is 0. 3x squared plus x squared is positive 4x squared. Remember, when you subtract a negative, you add the opposite. Bring down our next term. 4x, we'll figure out, sorry, x times what gives us 4x squared? Well, that's positive 4x. So 4x times x subtract 1 is 4x squared subtract 4x. We have 0. Negative 2x plus 4x is positive 2x. We'll bring down our next term, and that is 5. X times what gives us 2x? Well, that's 2. 2 times x subtract 1 is 2x subtract 2. And we're left with positive 7. So our remainder, 7. And if we want to write it in that form, it's exactly like last time. We would have our quotient, x cubed plus 3x squared subtract 2x plus 5 divided by x subtract 1 is equal to, well, what was on top, which was x squared plus 4x plus 2, plus our remainder, which was 7 over x subtract 1. And example C. Again, our restrictions, x cannot equal 2. And when we divide, one other thing to keep in mind is that when we are missing pieces, we need to go in descending order, but we have to fill in any missing pieces. So we've got a fourth term, plus we've got a cubic term, but because we have no squared term, we need to add in the 0 squared. Subtract 6x plus 1. You always, 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 always need to add in those missing terms. All right, 3 times, or blah, blah, blah. X times what gives us 3x to the fourth? That's 3x cubed. So 3x to the fourth, subtract 6x cubed. We end up with positive 8x cubed. So you don't necessarily need to do that stuff on the side like I was doing in the other steps. If you can do it in your head without making a mistake, go for it. And we bring down our next term. X times what gives us 8x cubed? Well, that's 8x squared. 8x squared times x is 8x cubed. 8x squared times negative 2 is negative 16x squared. We're going to subtract those. We end up with positive 16x squared. Bring down our negative 6x. X times what gives us 16x squared? Well, that's 16x. 16x times x is 16x squared. 16x times negative 2 is negative 32x. And we subtract. We're left with positive 26x. And we're going to bring down our last term, which is positive 1. And again, we think to ourselves, all right, x times what gives me 26x? That is 26. And if you can't math in your head, 26 times 2 is 52, negative 52. And when we subtract, we're left with 53. That means our remainder is 53. And you can put it in that same format as we did in all those other examples. I trust that you can fill in the information. Okay, so this part ends our sort of 3.2a. If you want to keep watching just to fill in the notes for the next day, that's totally fine. If you want to stop here, that's great. This might just be a heckin' long video. Okay, don't do what it says there, but yeah. Synthetic division. So synthetic division is a short form of division that uses only the coefficients of the terms, and it involves a few calculations. Personally, when it comes to dividing polynomials, this is what I use, but I mean, government decided we needed long division, so I have to teach you that one as well. Know that on a test, I will ask you to know both. Knowing one of them isn't good enough. All right, so what this looks like is similar format. Again, you need to make sure things are in descending order and that you have all your terms filled in. So to start off synthetic division, I draw this lovely, beautiful box. I'm going to put in my coefficients. So 2, 5, negative 1, and negative 6. Those come from our given equation. And then we're dividing it by x plus 2. Your first step is to bring down the 2. And then you ask yourself, okay, 2 times positive 2 is 4. You write that in the next blank. And then you subtract each of the terms. So 5 subtract 4 is 1. Next up, we go back, we ask 1 times 2 is 2. We put that in the next blank. Negative 1 subtract 2 is negative 3. We're going to ask ourselves, okay, negative 3 times 2 is negative 6. Negative 6 subtract negative 6 is 0. This last term is our remainder. So now we're going to fill in what we know. So we know when we divide, therefore, these are all, our 2, 1, and our negative 3 are all the x's in our next one. And so you start, we had a cubed. Our answer starts 1 lower. So 2x squared, so squared being 1 lower than cubed. And then you just keep filling it in. Plus 1x subtract 3, remainder 0. Example 3, divide the following and then state it in our P of x, Q of x form. State any restrictions. Ooh, forgot to do that on the last one. The last restriction was x could not be equal to negative 2. This one, our restriction is x cannot equal negative 3. So our first step, we write our coefficients 2, negative 5, negative 4, positive 2. You don't need the plus, it's there for fun. And we're going x plus 3. So when we divide, we bring, first step, bring our 2 down. 2 times positive 3 is 6. Negative 5 subtract 6 is negative 11. Negative 11 times 3 is negative 33. So we're going to, negative 4 subtract negative 33 is 29. 29 times 3, oh, is a large number. 29 times 3, 7, 2, 87. So positive 87. 2 subtract 87 is negative 85. That last term is our remainder. So if we're putting it in that p of x form, that would be 2x cubed subtract 5x squared subtract 4x plus 2 over x plus 3 is equal to our quotient, which is what we had left. So 2x squared subtract 11x plus 29 plus our remainder. So subtract 85 over x plus 3. I really hope that there's, no math errors. Hopefully let me know if I need to redo something because I made a math error. Things happen. All right, same one. Make sure it's in descending order. And it is. All our terms are filled in. 3, 4, negative 13, 4, and x subtract 2. Bring down our first number. 3 times negative 2 is negative 6. 4 subtract negative 6 is 10. 10 times negative 2 is negative 20. 13 subtract negative 20 is positive 7. 7 times negative 2 is negative 14. 4 subtract negative 14 is positive 18. That is our remainder. So our function is 3x squared plus 10x plus 7, remainder 18. And you can put it in that last form as last one. That's what it's asking us to do. That's just, a lot of writing, so I'm not going to do it. And C, again, things we need to have is we need to have all our terms filled in and make sure they're in descending order. So we have a fourth and we have a constant term. So there's a really an invisible one, so that's our fourth term, our third, our squared, our linear, and our constant. And we're dividing by x subtract 1. So bring down our 1. 1 times negative 1 is negative 1. 0 subtract negative 1 is 1. 1 times negative 1 is negative 1. 0 subtract negative 1 is 1. 1 times negative 1 is negative 1. 0 subtract negative 1 is 1. 1 times negative 1 is negative 1. 1 subtract negative 1 is 2. There's our remainder. So our function would be x cubed plus x squared plus x plus 1, remainder 2. Ignore those. We're moving on. All right, so our last piece is our remainder theorem. So when a polynomial, so polynomial being represented by p of x, is divided by a binomial, which is x subtract a, the remainder is p of a. So recall we talked about, this is from example 1a, which we went over in our notes. Probably that would be our 3.2a day. You can use the remainder theorem to find out the remainder. So our p of x was our function. Our a was negative 2. That comes from the fact, so x plus 2 was what we were dividing by. Our a, remember, is in that form just like in our x subtract h. So it's really x subtract negative 2. The negative 2 is what we care about. So if we were to put those in and figure out what our remainder would be, to check our a, so p of negative 2 is 2 times our a, so negative 2 cubed plus 5 times negative 2 squared, subtract negative 2, subtract 6. All we're doing is plugging our a in for our x. So we get, well, negative 2 cubed is negative 8 times 2 is negative 16. Negative 2 squared is 4. 4 times 5 is 20. Subtract negative 2 is add 2, subtract 6. So negative 16 plus 20 is 4, plus 2 is 6. 6 subtract 6 is 0. So we have, this is telling us it's a remainder of 0. So what that means is if the remainder is 0, then the binomial is a factor. Well, our remainder was 0, so that means x plus 2 is a factor. If the remainder is not 0, then that binomial is not a factor of p of x. This is an idea that we may use, in calculus, but we're going to use it now too. So example 4, use the remainder theorem to determine the remainder when p of x is equal to 3x to the 4 subtract x cubed subtract 5 and is divided by x subtract 3. So we're saying, if we're looking at that x subtract a to figure out what our a is, well, this is x subtract positive 3. So our a is positive 3. So p of 3 is equal to 3 times 3 to the power of 4 subtract 3 cubed subtract 5. Well, that gives us 3 to the power of 4 is a large number times 3 is 243. Did that on my head. 3 cubed is 27. Subtract 5. Well, if we look at this, we don't even need to finish that problem. We can say for sure that that's not going to equal 0. So therefore, x subtract 3 is not a factor. Example 5, determine the value of k if the remainder is -2 when that function divided by x subtract 2. Well, in this case, it's saying the remainder, so that's our p of x, that is 2, or -2. So this is saying when we figure out our remainder, we have a -2 left. We know our a is equal to 2. So p of 2 is equal to -2. We'll use that idea to use our equation. So we were always saying p of x is equal to whatever our function was with our a filled in. So in this case, -2 is equal to k 2 cubed subtract 4 2 squared subtract 5 times 2 plus 8. And we're just going to solve for k. -2 is equal to 8k subtract 16 subtract 10 plus 8. So -2 is equal to 8k. -16 subtract 10 is -26 plus 8 is a number 18, -18. And if we add that to both sides, we end up with 16 is equal to 8k. Divide both sides by 8. K is equal to 2. All that's saying is when that k value in our function is 2, we get a remainder of -2. So example 6, for what value of m will the polynomial, that polynomial there, have the same remainder when it's divided by x subtract 1 and x plus 2? So if we have, so in here we'd have an a that's equal to 1. Here we'd have an a that's equal to -2. We want to say what would the remainder, or we want that remainder to be equal when we have both of those functions. So p of 1 is equal to 1 cubed plus 6, 1 squared plus m times 1 subtract 4. That's one equation. We also have the equation when we have a -2. So p of -2, I'm going to squish this in. -2 cubed plus 6 times -2 plus m times -2 subtract 4. If we're to simplify those, we get p of 1 is equal to 1 plus 6 plus m subtract 4, which p of 1 is equal to m 7 subtract 4 is 3, m plus 3. And our other equation, p of -2 is equal to -2 cubed is -8 plus 12 plus subtract -2m subtract 4. So -8 plus 12 is 4. Oh my gosh. Hold on. I forgot the squared. Boop, 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 boop. This is Negative 2 squared is 4. 4 times 6 is 24. There we go. Sorry, people. Negative 8 plus 24 is positive 16. Subtract 4 is positive 12. So P of negative 2 is equal to negative 2m plus 12. Well, we want to figure out when they're remainders. So when that P of negative 2 and that P of 1, when those are equal, what is m? So we're going to use substitution. So we know that P of 1 and P of negative 2 technically are the same value. It's just like saying they're y's. When they're equal, so we can go m plus 3 is equal to negative 2m plus 12. And we'll solve for m. So 3m is equal to 9. Divide by 3. M is equal to 3. So when we have m in our original equations as 3, we would end up with the same remainder if we both had an a of negative 2 and an a of 1. That's it, that's all.